In this video, we'll be discussing function notation. We often use f, g, and h to name functions. So when we see this notation right here, this is read f of x. What it's saying is f is a function of x. But please, it's not f times x. We say this f of x. Basically, all we're doing when we want to write something in function notation is we're replacing the y with f of x, g of x, h of x, etc. So here on the right, we're just going to take this equation and replace the y with f of x. Oftentimes, we are asked to evaluate functions that are in function notation. So like in this first example, given f of x equals negative 2x plus 6 divided by 3x, we want to find f of 1 and f of negative 3. Well, you've actually done problems like this before. Let me just take it out of function notation and show you what the problem was that you've done in previous courses. This is the same as saying y equals negative 2x plus 6 over 3x. What is y when x equals 1? And how do we figure that out? Well, we just take the 1 and we plug it in for x, and then we clean it up using order of operations, and that's our answer. Exact same thing that we're going to do here. To find f of 1, I'm simply replacing all the x's in my function f of x with the number 1, and then we'll clean it up. I want to be very clear here. Do not mess with this left-hand side at all. F of 1 is a notation. That's not f times 1. You're not allowed to divide both sides by 1. That is a notation that all goes together. Don't ever mess with it. The right side, however, that's what we'll be cleaning up. And we're just going to do order of operations. So negative 2 times 1 is negative 2 plus 6. 3 times 1 on the bottom is 3. So f of negative 1 is going to be 4 over 3. That's our answer. Let's evaluate this function again, this time at negative 3. So let's find f of negative 3. Everywhere we have an x in our function f, we're going to replace it with negative 3. And now we clean it up using our order of operations. F of negative 3, that's going to be a negative times a negative, positive 6 plus 6 over negative 9. F of negative 3 will be 12 divided by negative 9. And we know we can simplify that fraction. F of negative 3 is equal to negative 4/3. Let's try another one. Given k of x equals 3x plus 5, let's find k of negative x and k of a minus 3. Starting with k of negative x, all we're doing is replacing the x and k with negative x. We get 3 times negative x plus 5. Right, it's just a direct replacement. And now we clean it up. Multiplying 3 times negative x, we get negative 3x plus 5. There's no other simplifying or combining that can be done. K of negative x equals negative 3x plus 5. Next, we want to find k of a minus 3. This time, we're going to replace the x in k with the quantity a minus 3 instead. We'll have 3 times the quantity a minus 3 plus 5. Just like in the previous example, it's just a direct replacement. I replace the x in k of x with that quantity a minus 3. Now we want to clean it up by distributing and combining like terms. We get 3a minus 9 plus 5. K of a minus 3 equals 3a minus 4. We have one last example to look at. Given g of x equals x squared minus 2x plus 3, let's find g of x minus 1. We're going to replace every x in our given g, which is here and here. We're going to replace them with the quantity x minus 1. That gives us x minus 1, quantity squared, minus 2 times the quantity x minus 1 plus 3. And now we simplify it. Notice that x minus 1 quantity squared, that's a binomial squared. Because of the minus sign inside of the parentheses, we're going to have to write this twice and multiply it out. We'd have to do the same if it was a plus sign in there as well. We'll write this twice and multiply it out. In our next term, we'll distribute negative 2. It'll be a negative 2x plus 2, and then our plus 3 comes straight down. Multiplying these binomials together, we get x squared minus 1x plus 1. And notice I have some like terms here we can combine. So plus 1 minus 2x plus 5. And again, we want to combine any like terms that we have. Notice we have both linear terms that we can combine, and we have constant terms that we can combine. G of x minus 1 is x squared minus 4x plus 6. And that's how we evaluate functions in function notation.